Suppose we were given the acceleration of a particle, and let's say that the particle is traveling on the x-axis. And so we were given that the initial the velocity at time 1 was 8, and the position at time 0 was 8 also. So what that means is at time 0, the little particle was at the point 8, 0. This 8 is from this 8 right here, x equals 8. This 0 is because he's traveling on the x-axis, so y equals 0. It is not this 0 right here. This is the time. So at time 0, he was at an x position of 8, and since he's on the x-axis, he's on a y position of 0. So if I want to get to the position equation, or let's say we want the velocity equation, the position equation, and then from there we'll keep going. The first thing I'm going to have to do is take the antiderivative. I'm starting with acceleration and I want velocity, so I'm going to work backwards. So it's 6t to the first right now, so I'm going to raise the power by 1, so t squared, divide by 2, so add 1 here, divide by 2. 6 divided by 2 is 3. This 3 that's sitting here, this constant, doesn't have a t, but if you need one, you can put t to the 0. So plus, I know that when I raise the power, it will be a t to the first, divide by the 1, and I've got a 3, plus c. Well, I was given an initial velocity, v of 1 equals 8. So I can plug that in to solve for this c. So my velocity is 8 when t equals 1. So 3 times 1 squared plus 3 times 1 plus c. So 8 equals 3 plus 3 plus c. So that implies that c must equal 2. So my velocity equation would be 3t squared plus 3t plus 2. If I then wanted my position equation, I'm going to have to take the antiderivative again. So x of t will equal, and if I raise the power, that becomes a t cubed, divide by my 3, and that's a 1, so just t cubed. If I raise the power of this, it becomes a t squared, divide by my 2, so plus 3 halves, t squared. This doesn't have a t, so it's t to the 0. Raise the power by 1, it's t to the first, divide by 1, so plus 2t plus c. Well, I was given this as my initial position. At time 0, it's at an x position of 8. So I'm going to plug in 8 for my x and zeros for my t's. So 8 equals 0 plus 0 plus 0 plus c. So I now know my position equation, which is t cubed plus 3 halves t squared plus 2t plus 8. So if somebody wanted the position when t equals 2, then I can just come over here and say, okay, it's going to be the x value at time 2 is 2 cubed plus 3 halves times 2 squared plus 2 times 2 plus 8. So this will equal 8. Then one of these 2's cancels out, leaving this with 6 plus 4 plus 8. And 8 plus 6 is 14 plus 4 is 18 plus 8 is 26. So I know that x of 2 is equal to 26. If I wanted to give it as a coordinate point, I know that at time 2 it's an x value of 26 and a y value of 0. If someone asked when is velocity increasing, well, we don't do things analytically, proving this increasing, decreasing. What we like are positives and negatives because those are easy. Showing something's positive or negative is a lot easier than increasing. So what I'm going to do is look at the slope of velocity. So if the velocity is increasing, then I know that its slope is positive. and the slope of velocity is acceleration. So what I'm looking for is if the velocity is increasing, when is the acceleration positive? So I want to know when is a of t greater than 0. So to do that, I'm going to take my a of t, 6t plus 3, and set it equal to 0 and solve for t. So subtract 3 from both sides, divide by 6, and we have a negative 1/2. So the question comes in, can you have a negative time? Well, probably not, but it didn't specifically say t greater than or equal to 0. I'm going to assume that t is greater than or equal to 0. So this is the only time that the acceleration is equal to 0. That doesn't mean you can't do the problem. The interval I'm looking at is from 0 to infinity. Let's say we start time at 0, it goes to infinity. What that means is in this interval, the acceleration will either be positive the entire time or negative the entire time. To find that out, you take a test value from this interval, let's say 1, and you can plug it into the acceleration function. 6 times 1 plus 3 is positive. So the acceleration is positive on this entire interval, and that is when the velocity is increasing.